Welcome back to the vBrownbag Tech Talks at vForum in Sydney. My next guest is the unstoppable Vaughn Stewart, who's here to talk to us about solving I/O issues with Flash.
Hey, thanks for having me on, Alistair. I love the vBrownbags. I'm excited to be here in Sydney again at the vForum. For those of you who may not know, I'm Vaughn Stewart, formerly of NetApp, recently of Pure Storage. I want to talk to you about solving I/O issues with flash storage, or as I say, Flash. From having a long history of providing storage platforms in support of virtual infrastructures and cloud computing, and predominantly with VMware, but with a number of other vendors, including Citrix and Microsoft, Red Hat. What we've seen occur over the last couple of years is this tremendous adoption and shift in computing models within the enterprise and then the uprise of cloud service providers. And for all the gains that sort of virtualization has brought in terms of how we consume data center resources and provide them to the end users for running their applications, storage has been an area of technology that's caused a lot of challenges, brought a lot of challenges to bear, has been a point of frustration, I think it's fair to say, for a number of virtual infrastructure or cloud infrastructure operators and administrators. And you know, while the software technology continues to evolve at the hypervisor, virtual infrastructure, and orchestration layer, storage has been kind of just inching along over the course of the last several years. With traditional storage arrays, and you could pick between SAN and NAS, and you know, from 2006 to say 2009 or 10, there was a lot of discussion in that area around the benefits one or the other over simplicity or scaling. You know, technology's advanced, and that's no longer an issue. And we had discussions around storage efficiency technology. You know, could we jam more data on disk and drive down the cost of that shared infrastructure? And again, that technology has ran that curve. And what customers have been struggling with over the course of the last 2 years, a solid 2 years, has been they run out of performance or I/O within their virtual infrastructure. They have tons of capacity. They can buy more disk drives, larger disk drives. It's the amount of performance that they can achieve from their storage platforms. And so when you look at the market in a broad sense, you see a ton of innovation occurring within the storage space, particularly around virtualization. And I'd like to share with you my view on these three areas and kind of talk pros and cons, and maybe help give some guidelines to the audience around how they can solve some of their storage challenges. The area I'm going to focus on is flash technology. And so let's start with the first area, which is in the realm of caching. Flash storage, well actually I should back up. Flash storage compared to disk storage, both can store data and serve data in a traditional means that you're used to within LUNs and file systems. But disk storage today is really geared towards being very cost effective on a per gigabyte in terms of storage capacity, very expensive on an IOP perspective. In other words, large density disks with low performance capabilities. By contrast, on the other end of the spectrum, you have flash storage, which is solid state. It is very expensive on the per gigabyte or the capacity side, but very inexpensive on the IOP side. A flash drive has somewhere in the realm of 100 times the IOP capacity of a spinning or rotational disk drive. And so as we look to bring flash technologies into the infrastructure to accelerate storage performance, we can do so in a number of ways. And the first way is by looking at flash as a caching mechanism that runs alongside with spinning disk drives. So the means that we can consume flash in a caching model is usually either by adding it to the storage array and building a cache tier, or I can put it inside of the host and put my cache tier closer to the hypervisor. In these two models, the benefits are very similar. There are some differences from the perspective of when I add flash to spinning disk in a storage array, what I'm doing is reducing the I/O load on the actual spinning disk itself. By contrast, when I put flash into the host, I'm actually reducing the total I/O array or I/O load on this total store. I'm reducing I/O load on the entire storage array. So again, difference between taking I/O load off the back end disk or I/O load off the entire array. How the caching mechanism works is, should a virtual machine request a block or a range of data, it will be stored in the cache. and should there be a subsequent request for that data, it'll be serviced from the cache before going all the way back to the back end of the disk. And the benefit of this architecture is it helps reduce the latency for retrieving previously accessed data and reducing the overall call all the way to the back end, high latency spinning disk drive media. The long story short on this is if you have a storage platform that has spinning disk, that has the ability for you to either add cache to it or surround the array with cache inside of the host, you will gain performance within your infrastructure. How much you gain is going to be variable based on your applications and how cacheable or cache-friendly your data set is, but trust me here, in a very blanket statement, you will receive some form of benefit from this technology. Now the reason why I say some form is, and I'm not trying to shortchange this, is depending on your applications and how the workload is structured, many applications set out a bunch of IOs that make up a transaction, and a transaction is kind of like a serialized number of IO requests. And if 90% of those can be serviced from the cache, you get a very fast response time. But if 10% of those have to come back from the spinning disk, then that entire transaction is actually weighted down and reliant upon the slowest element within the storage subsystem, which is the spinning disk. And so what you tend to see with cache-based solutions is an inconsistency in delivering a consistent state of performance. It'll get averaged into an overall response time that will be faster than spinning disk. But again, depending on your application and how sensitive it is to latency, it may or may not have a big impact on your infrastructure. A second area where we're seeing flash come into the data center is in this design of a distributed DAS storage platform, such as what you see with VMware vSAN, Microsoft storage spaces. This is also a construct you see within some of the new storage vendors like Nutanix, where the model of this is to combine spinning disk drives for capacity, some flash media for a cache, and instead of having a shared infrastructure, they have a distributed infrastructure where the data set is mirrored, usually three mirrored copies at a production site. And this is a means to provide high availability and high performance by having just a lot of hardware and multiple failure domains within the infrastructure. These technologies are emerging as a means to try to improve performance through the volume of hardware, as well as trying to reduce the cost within an infrastructure of having to deploy enterprise class storage and particularly flash storage. Now this technology is emerging and carries a lot of promise with it. The data points that VMware and other vendors have shared in this space has shown that high IOPS are available through this model and architecture, as well as the design can be highly available. So I think there's going to be some adoption within this space with vSAN and the technologies like this. I think the downside of this technology is that it will inevitably consume more rack space than a traditional shared storage infrastructure. Allow me to explain that in a little bit greater detail. Because the distributed DAS architecture requires 3 copies of data to achieve 5 nines availability, that means if I have a terabyte of data required to run my production environment, it means I need 3 terabytes of data to store it on disk. That means that as a byproduct, I will consume 3 times the amount of rack space and infrastructure or data center resources to run that load. So as long as my infrastructure is either capable because I have excess capacity, then this is probably an attractive model, or maybe more likely at those remote offices, remote data centers where I don't have a lot of capacity or maybe can't afford to purchase a shared storage device. This combination of compute, network, and storage together probably becomes very attractive for those small footprints, even though it is triple copy. The last area where we're seeing a big advancement within the storage space is in the all-flash storage arrays. And there tends to be 2 flavors of shared storage platforms that leverage all-flash. There's the storage vendors that bring in flash and tout it as a tier 0 highest performance type of design, and with that highest performance is also the highest price point available. And those architectures tend to get put into very specific use cases and workloads and aren't designed from a pure financial standpoint for a broad adoption and a broad appeal to the market. There's a second set of all-flash storage arrays that combine the promise of delivering the performance of all-flash along with storage savings technologies to bring flash down to a price point that's equal to, or in some cases less than, spinning disk. And by this model, the offering of all flash is a direct replacement for your existing storage platform. So the goal within this technology, and in full disclosure, I work for Pure Storage, and our product, the Flash Array, provides an architecture that is the latter. We combine all flash storage device that's built off of commodity components, from Intel CPUs down to consumer grade MLC solid state drives, and we combine that with inline data deduplication, compression, and pattern removal to drive that price point down. For us, for example, we are able to globally provide a 6-to-1 data reduction for our customers. This is real data comprised from the phone home element within the controller. That is really the justification for the price of the device. But more importantly is when you look at terms of how does this performance relate to driving my applications or my data center forward. Instead of touting about the highest level of IOPS, saying 400,000 IOPS at 1 millisecond latency, things of that nature, which is a classic storage pitch, I'd like to actually turn the conversation and talk about what this means to you as an operator of a virtual infrastructure or cloud platform. By being able to have a storage platform that has a massive amount of IOPS, what you're actually receiving is a means to deliver consistent performance and to have a platform that is resilient to unexpected changes within the workload. What we are finding as we are moving further along the maturation curve of cloud computing infrastructure is you as the infrastructure owner build the environment, but you don't have much in terms of control over the configuration of the virtual machine, or the file system, the application, or the use within it. You are much more in a model of like a service provider, whether, particularly if you're like in the enterprise data center or even mid-sized business. And so having an architecture that's resilient to whatever behaviors may be exhibited inside of the virtual machine or by your end user community, by being able to have that resiliency within the storage platform ensures that your phone doesn't ring at the middle of the night and that your end users or your customers are satisfied. So let me back up here and summarize kind of what we talked about. Storage is being challenged to keep in line and up to pace with cloud computing. The advancements delivered by VMware and the rest of the other virtualization vendors have radically changed how data center resources are consumed and utilized. Flash is being brought in as a means to help solve the challenges within the storage space. There are models within Flash that allow you to use it as a cache, which will provide immediate benefits to your existing storage platforms. There are means for you to look at new architectures such as distributed DAS, which combine spinning disk and Flash again as a cache, as a means to try to build a new architecture that's comprised with storage in the servers. As well as there are a new generation of shared storage arrays that are built on all Flash, and the ones that are really appealing within the cloud infrastructure combined storage savings technologies so that they can bring the price point down to that of disk and ensure the customers to have great performance and consistent performance because they're not using Flash as a cache, but using Flash as actual persistent or data storage tier. So that's my summary. I hope it wasn't too high level for some of you. I realize it wasn't very low level for others. I'll share more details in terms of my thoughts around Flash and the consumption models of Flash technologies on my blog, virtualstorageguy.com. Again, this has been Vaughn Stewart. I thank you for your time. I hope this wasn't too long. And I want to thank the vBrownbag for having me on. Thanks, guys.
Thanks, Vaughn. It's always a pleasure to have you come in and join us and bring some insights in.